All right, guys. So welcome to this, exam review. We're just gonna go through the questions, and that way you can do your corrections. So let's look at the first problem here. So we want to rewrite this using rational exponents. So remember, the rule is power over index. All right, so it's the variable to the power over the index. So the index is the number, that's the index, and then that's the power, right? In this example, the index is an invisible 2 since we're dealing with square root. So we have x to the power over index, y to the power for y is 1, power over index. Alright, so that's all they wanted. They wanted you to just rewrite it using rational exponents. Alright, for number 2, simplify the expression. So essentially we're going to break this up into a few different cube roots. So we have cube root of 24. And then we're going to rewrite these using rational exponents, so using the fractional powers. So we have x to the power over index, y to the power over index, and z to the power over index. Alright, so now we're going to break the 24. 24 can break into 8 and 3. And the cube root of 8 is 2 because 2 times 2 times 2 is 8. So this can break up into cube root of 8 and cube root of 2. And then 15 divided by 3 is 5. 9 divided by 3 is 3. And 1 divided by 1 is to the first power. Cube root of 8 we said was 2. So we have 2 cube root of 2, x to the 5th, y to the 3rd, and z. Alright, solve the given radical equation. So now we just want to solve this guy. So we're going to get rid of the square root by squaring both sides. Okay, so I'll write it out here. Alright, so we just have x squared on the one side. And we have x plus 2 on the other side, since the square and the square root cancel. And now we have a quadratic equation because the highest power is 2. So remember, we want to set quadratics equal to 0. So I'm going to subtract the x and I'm going to subtract the 2 onto the other side, because I want that one side to be 0. So I have x squared minus x minus 2 equal to 0. Alright, so at this point we need to see if we can factor here. So we want the factors of negative 2 that add up to negative 1, which in this case would be negative 2 and positive 1. So we can factor this, x minus 2, x plus 1 equals 0. And then solve this, so you have basically x minus 2 equal to 0, and you have x plus 1 equal to 0. So what makes this 0? Well, x is equal to 2 makes that 0, and x is equal to negative 1 makes that 0. Alright, and then what you want to do is you want to check your solution. So this is where we check it. So we're going to plug in x equal to 2 here. So we have 2 equals square root of 2 plus 2. So 2 equals square root of 4, which is true. Now let's plug in x is equal to negative 1. We have negative 1 equals square root of negative 1 plus 2. Negative 1 equals square root of 1. Negative 1 does not equal to 1, so this is not true. So that's not a solution. So cross that out since that's extraneous. So your final solution is x is equal to 2. Alright, So let's rewrite this using radicals. So pretty straightforward. Remember, power over index. So it's a to the power over index. So we have a to the 5th power with an index of 4. And then b to the 1st power with an index of 2. But again, we don't usually write the 2 into 1, so we can just rewrite it as 4th root of a to the 5th times square root of b. All right, next one. So number 5. A basketball player shoots a ball into the air. The velocity of the ball at the maximum height, neglecting the player's height, can be given by the function below, where g is the gravitational acceleration, which is 10 meters per second squared. V is the velocity, and h is the height of the ball. What is the maximum height of the ball if the ball is shot at a velocity of 4 meters per second? So we know that the velocity is 4 meters per second. We know that the g is 10 meters per second squared, and these are just units, okay? So don't worry about the units too much. And that's all we need, because we want to, let's see. Yeah, so that's all we need. So we're going to plug in the numbers. So we have 4 equals square root of 2 times 10 times h. So we have 4 equals square root of 20h. So we got to get rid of the square root first. So we're going to square both sides. So that leaves us with 16 equals 20h. Then we can divide by 20 on both sides. So h is equal to 16 over 20, which this reduces. So 16 over 20, we can divide that by 4 on the top and bottom. So that gives us 4/5. So h is equal to 4/5 meters. All right. All right, to graph the function below, you must take the graph of the parent function and horizontally stretch it by a factor of 2. So the graph below is given by 2 times square root of x minus 1, and they want to see is this true or false. Okay, so if you take this function, well, this 2 right here means that you're going to vertically stretch it, not horizontally stretch it, right? So that's not right. Horizontal stretch would look like horizontal stretch would be if you had a 1/2, you know, in front of the x, you know, like that, where you have the 1/2 in the radical with the x. That would be a horizontal stretch, right? But in this case, vertical stretch is the correct answer. It's not horizontal stretch. So that means this is false. Okay, since it's not a horizontal stretch. Simplify the expression. So we're going to rewrite this in terms of radicals. So remember, it's power over index. So we have 6 over 3 is 2, so we have x minus 2 to the 2nd power. And remember, if we're doing a cube root, we're just going to leave it like as so. So that's our final answer. Write the new function given the following transformations of the parent function. So we are going to shift to the right 3 units. All right, so let's do that. So shifting right 3 units, meaning that, you know, it's gonna have a minus 3 on the inside, right? So that's for that. Shifting up 4 units means that we're gonna have a plus 4 on the outside. Reflecting across the y-axis means that we're gonna have a negative in the inside, and a vertical stretch by a factor of 1/2 or this should say vertical compression, not stretch, by a factor of 1/2, so it's 1/2 on the outside. All right, so we're going to put those together. So our new function, we're going to call it g of x. It doesn't really matter what it's called. It's 1/2. That's the vertical stretch. We have a negative in front of the x. So we have a negative in front of the x, and we have minus, and it shifts to the right 3 units. Okay, so shift to the right, and then there's a negative in front of it, and then shift up 4 units. Okay, so that's everything. Vertical stretch, or vertical compression. We have a reflection across the y-axis, and we have a shift to the right 3, and then we're going up 4. All right, so now we're going to perform the indicated operation, simplify and write an answer in radical form. So notice that this fraction in here reduces, so this becomes 4, so we can divide this by 4. So divide this by 4 and divide that by 4. So that becomes 1/4. So I'm going to do that before I do anything else. So that becomes 1/4 right there. Excuse me. So becomes a 1/4. Now we can, since we're dividing, since this has an index of 2 and this has an index of 3, we're going to have to rewrite this in terms of fractional powers. So we have x to the power over index, y to the power over index, x to the power over index, y to the power over index. So we have here x to the 3/2, y to the 4th, x to the 4/3, y to the 5/3. So we need to subtract these exponents. Since we are dividing, we subtract exponents. So we have x to the 3. So I'm going to pull this 1/4 out right here, this invisible 1/4 there. I'm going to pull that out. And then I have x to the 3/2 minus 4/3, y to the 4/1 minus 5/3. So we need to combine those fractions. So we need a common denominator. So let me just do this on the side. So we need a common denominator of 6. So I need to times this by, oops. So I need to times this by 3 and times that by 3. I need a common denominator of 6. I need to times that by 2, times that by 2. So that gives me 9/6 minus 8/6, which is 1/6. Okay, so we have 1/4 x to the 1/6. And then we have here y to the, sorry, let me do this one separately now. So we have 4/1 minus 5/3. So again, we need a common denominator of 3, so times this by 3, times that by 3. So we have 12/3 minus 5/3, which is 7/3. All right, so y to the 7/3. So we're almost there. So I'm going to rewrite the x as 6√(x). Remember, it's power over index, so the power is 1, and then the index is 6. For 7/3, 7/3 is the same thing as 2 and 1/3. Okay, so 2 and 1/3 is the same thing as 7/3. So I have y to the 2nd and y to the 1/3. All right, so y to the 1/3 is simply cube root. So I'm going to put the y squared in front of the 1/4. We have cube root of x, or 6√(x), sorry. And the y here becomes cube root. Remember, it's power over index, and the index is 3. All right, and that's your final answer. All right, so number 10, perform the indicated operation, simplify and write the answer in radical form. So we know that 8 divided by 2 is 4, so that takes care of the 4 there. Now, since these are under the same radical, I can put the radical in over the top of both of them and then divide them. We can only do that if they have the same index. Here they have the same index, which is 2, so we can do this. In the other example, we could not do it because one was a square root and one was a cube root. So now we can go ahead and start subtracting. So we have x to the 3 minus 4, y to the 8 minus 5. So this gives us x to the negative 1, y to the third. So y to the third is also, we're good with y to the third. Let's rewrite the x to the negative 1. Remember, negative power means flip and forget. So that means we're going to flip the x. All right, we're going to flip it down to the bottom. So that means we have y to the third on top, but the x flips to the bottom. And then we have an invisible positive 1 power there. It becomes positive. The negative exponent now becomes positive. All right, let's rewrite the y as y to the power over index and invisible 2 there. And I'm going to leave the x alone just because there's nothing else I can do with it. However, for this guy, we can 3 halves is the same thing as 1 and 1/2. So this becomes 4 y to the first, y to the 1/2. Okay, so since I took the square root, I need to make sure that I include the absolute value there. Every time you take a square root or an even index, you need to include the absolute value. If this was over 3 or over 6 or over 7, and if it was a cube root or a fifth root, then we don't need the absolute value. So we need to make sure to include the absolute value for even roots. This is just square root of y, and then square root of x. So then you can put this under 1 radical, and there you go. And that's your final answer. And this is without rationalizing, so we're assuming that we're not rationalizing in this example. All right, because we didn't at this point we hadn't gone over rationalizing denominators. All right, what are the solutions, if any, for the given radical equation? All right, so we're going to solve this guy. If you want, you can you replace this with a square root. So you can, replace this with a square root, as so. And then we're going to subtract 5 on both sides. So now we're going to square both sides. Subtract 1 on both sides. Then divide by 3 on both sides. All right, and that's your solution. X equals 5. Oh, but then we have to check it, right? So let's check the solution to see if it's actually true, because you never know. All right, so we have 3 times 5 plus 1 square root plus 5 equals 9. So square root of 15 plus 1, square root of 16, and 4 plus 5 equals 9, so that checks out. So yeah, so that's our solution. All right, so simplify the following expression. So we need to, we have a cube root, we need to break this up into different cube roots. So we have cube root of 32, and I'm going to rewrite the powers as fractional, the variables as fractional powers. So this will be x to the power over index, y to the power over index. Okay. So we know that 32 can be broken into, so 8 and 4, and the cube root of 8 is 2. Okay, so this can be broken down as to cube root of 8 and cube root of 4. Now we have, now what we're gonna do is 5/3 is the same thing as 1 and 2/3. So I'm gonna break it into x to the first power and x to the 2/3 power. And then y is just gonna be to the first power. Alright, so the cube root of 8 is 2, so we have 2 cube root of 4, and then we have xy, so that's these guys there. And then we're going to rewrite this as a radical now, so that would be cube root of x squared. That's it. Alright, perform the indicated operation, simplify and write the answer in rational form. So, and this should say radical form, not rational form. So it should say radical. Alright, so notice that we have an invisible 1 here. So we have 1 of these guys and we have 7 of these guys. So we can combine these guys only because they have this, they're like terms. So we have a total of 8 of those guys. However, we can't combine that because this is x squared y to the 4th, and that's x cubed y to the 6th. All right, so we can't combine those. So, so these guys are like terms, but that is not. Okay. So we're just going to leave this hanging here, and then we're going to simplify. So we're going to rewrite this as x to the power over index, invisible 2 there for square root, y to the 6th power over index, 2x to the power over index, y to the power over index. So 3 over 2 is the same. So 3 over 2 is the same thing as 1 and 1/2. So we have 8x to the 1 power. Since we did a square root, we need absolute value. And then x to the 1/2 power, y to the 3rd power. Since we did square root, we put absolute value. 2x to the 1 power. Since we did square root, we needed absolute value. And then same for the y squared. We're just going to put an absolute value around it. So we have 8 absolute value of xy to the 3rd. Now x to the 1/2 is the same thing as square root, power over index, okay? The power over index there, 1/2 power. And then 2 absolute value xy squared. All right, and we'll just leave it like that. All right, so given the following equation, how many extraneous solutions are there? So, so we're going to solve this equation by squaring both sides. So we've got to get rid of the square root, so square both sides. So that gets rid of it. Now we have x minus 3 on the left side, and this we're going to have to FOIL. Okay? So again, remember first, outer, inner, and last. Okay? So first, 5 times 5 is 25. Outer, 5 times negative x is negative 5x. Inner, negative x times 5 is negative 5x. And outer, x times x is positive x squared. Negative x times negative x is positive x squared. Alright, we're going to combine like terms here. We can combine these two like terms. Negative 5 and negative 5x is negative 10x. This is quadratic because the power is 2. So we're going to make one side equal to 0, so I'm going to subtract everything. I'm going to get rid of everything on the left side and move it over to the right side. So that's 0 on that side. And we have 28, this is negative 10 minus 1, so that's negative 11x. And then you have your x squared. Alright, so I'm going to rewrite this with the x squared going first. So x squared minus 11x plus 28 equal to 0. So that looks nicer. Now we can factor that, the factors of 28 that add up to negative 11, which in this case is negative 4 and negative 7. So we have x minus 4 times x minus 7 equals 0. X is equal to 4 and 7. So far those are our solutions. We need to plug them in, so let's check. So we're going to plug in x equal to 4 first. So we have square root. We're plugging it into the original. 4 minus 3 equals 5 minus 4. So we have square root of 1 equals 1, which that is true. Let's check x is equal to 7. Square root of 7 minus 3 equals 5 minus 7. So square root of 7 minus 3, that's square root of 4, and this is negative 2. So 2 does not equal to negative 2, so that means that this is not a solution. So that means the final answer is simply x is equal to 4. Which means that there's only one extraneous solution. So they're actually not asking for the solution, they're asking for how many extraneous solutions are there. So in this case, there's only one extraneous solution. So that's actually what they're asking about. They're not asking about anything else other than that. Alright, so we solved it to find out how many extraneous solutions there are. The extraneous solution in this case is x equal to 7 because that one didn't work out. Alright, 15. Assume the number of rabbits n in a given geographic area can be modeled by the function given below, where t is the time elapsed in days. How long will it be until there are a total of 500 rabbits in the area? So n is equal to 500, so 500 rabbits. T is, so this should say t, not x, okay? So that's a t. So t is the time elapsed in days. So yeah, we're simply plugging in 500 and solving for t. So plug it in 500, and so we have 500 equals 100 times the square root of 2t minus 1. So to solve this, we need to isolate the radical. So get rid of the 100 first by dividing it off. 500 divided by 100 is 5. So we need to square both sides. We have 25 equals 2t minus 1. Now we can add 1 on both sides. Then divide by 2 on both sides. We have t equals 13. So this is 13 days in this example. Alright, number 16, find an equation for the following graph. Alright, so notice that square root functions, the square root function looks like this. Alright, because if you think about it, square root of 1 is 1, so we have a point at 1, 1. And then square root of 4 is 2, so we have a point at 4, 2. So that's 1, 1, and then that's 4, 2. So that's how the square root function looks like. So this looks like the square root function if you look at it, right? So because that looks like the square root function, we know it's going to be square root, and we can tell that it's shifted to the right one. So that's going to be to the right one, and it's shifted up 1. Alright, so that means that my function is square root of x. Since we're shifting to the right one, I'm going to subtract 1, and then since we're shifting up 1, I'm going to add 1, and that is my transformed function. Alright, so number 17, perform the indicated operation, simplify and write the answer in radical form. Alright, so notice that if I'm multiplying radicals, if I have the same index, then I can multiply them together under the same index. Okay, so that's what I'm going to do for the fifth roots. So I'm going to rewrite those next to each other first. Okay, so I have fifth root of, so now I can multiply, so I have x squared, y to the fourth, times y to the ninth, and then I just have the cube root of x cubed. So now I can, when I multiply the y's, I need to add the exponents, okay? So I need to add those exponents. So y to the 13th power. And of course I have cube root of x cubed. So now let's write this as power over index. So we have x to the power over index, y to the power over index, and then we have x to the power over index. So x to the 2/5 is just x to the 2/5. There's nothing really else that we can do there. Y to the 13/5. So 13 over 5 is 2 3/5. So this is y to the second, y to the 3/5. And then x to the 3 over 3 is x to the 1. All right, so I'm going to put the x and the y squared first, kind of like I'm going to group those first, and then I'm going to rewrite these as radicals. All right, so I have power over index, so it's power over index, and then the y is power over index. And since they have the same radical, I'm going to group them together under the same radical. All right, and that's my final answer. All right, number 18, perform the indicated operation. Simplify and write the answer in radical form. Just say radical. All right, so we're going to, since these are different indexes, right? This is 2 and that's a 3. I'm just gonna write them out as fractional powers. 5 over 2, b to the 2 over 2, times a to the 8 over 3, b to the 4 over 3. So 5 over 2. 5 over 2 is the same thing as 2 and 1/2. 8 over 3 is the same thing as 2 2/3, because 3 goes into 8 twice, and then there's a remainder of 2. 4/3 is 1 1/3. 3 goes into 4 once with a remainder of 1. All right, so a to the second, this is 2.5, so and then a to the 1/2. Since I took the square root, I'm just going to write an absolute value there. And then we have b to the 1 power. Since I took the square root, I need an absolute value. For a to the 8/3, we have a to the 2 and a to the 2/3. Since I took a cube root, I don't really need the absolute value there. And then we have b to the 4/3, so which is b to the 1 1/3. Again, since I took a cube root, I don't need to put an absolute value there. So I'm going to put these in the 1 absolute value. Of course, we have the a squared there. I'm going to put the a squared in front, and I'm going to put the b in front as well. All right. And then we have, so now I'm going to rewrite the a to the 1/2 as square root of a. And then I'm going to write b to the, I'm just going to leave it as a to the 1/2. So I'm going to write as a to the 1/2. I have a to the 2/3. And then I'm going to rewrite the b. I'm going to write out the b to the 1/3. Okay? So I'm going to basically combine these two by adding them. All right, so we have all of this, and then I'm going to combine these. So 1/2 plus 2/3. So let's do that over here. So 1/2 plus 2/3. So I need a common denominator of 6. So I need to times this by 3, times this by 3. Common denominator 6, I need to times that by 2, times that by 2. So we have 3 over 6 plus 4 over 6, which is 7 over 6. So I have a to the 7 over 6, and then I have b to the 1/3. All right, I'm just going to rewrite this. A to the 7 over 6 is a to the 1, a to the 7 over, a to the 1 over 6. So 7, 6 is the same thing as 1 and 1, 6, which is how I got 1 and 1, 6. And then we have b to the 1/3. We're just simplifying a lot here. Since I did do an even root, I'm going to put an absolute value around there. So I'm going to combine those two absolute values together. So that gives me a to the 3rd in total, and b. I have the a squared b hanging out here, and I'm going to write these as radicals. So I have radical a to the 1st power 6 root, radical b to the 1st power cube root, power over index. All right, so I can leave the answer like this, or I can multiply the 3 and the 2 and make it a to the 5th, and then make this b squared. But I'm just going to leave it like this, just so that I won't mess with the absolute values. And plus, I believe the answer was matched to one of these, so we'll leave it like this. But you can combine the b's. Technically, you can. But since this was multiple choice, that was one of the answers. All right, number 19. Simplify the following expression. So we have index of 2, power of 9, so a to the power over index, b to the power over index. 9 over 2 is 2 goes into 9 4 times with a remainder of 1 over 2. So we have a to the 4, a to the 1/2. And b to the 8 over 2 is b to the 4. Since we took a square root, I'm just going to put an absolute value around those, even though technically it's not needed. But just for the sake of being consistent, I will put an absolute value. So you could do that, or you could write it as a to the 4th, b to the 4th, square root of a without the absolute value. Because technically these will always be positive, so it doesn't matter if there's absolute value there. But if you did put absolute value, it's still correct. All right, what is the domain for the following function? So the trick with domain is to set the radicand equal to 0. The radicand is a number inside the radical. So that is what tells you that is what helps you find the domain. Or you can graph it and figure out what the domain is. But we're just going to set that radicand equal to 0. So set the number inside the radical to 0 and then solve. All right, so x is equal to 2. So that means that we know that we cannot take the square root of a negative number, right? We can't take the square root of a negative number, but we can take the square root of 0. That's 0, right? So we know that this has to be greater than or equal to, so the radicand has to be greater than or equal to 0. Okay, so whatever is inside there has to be bigger than 0 or greater than 0, because we can take the square root of positive numbers, right? But we can't take the square root of negative numbers. So we know that this right here has to be greater than or equal to 0. So I'm going to change this to greater than or equal to 0. So I know that x has to be greater than or equal to 2. So like if x were 2, we're going to get 0 here, right? If x were like 3, then we'll get, 2 times 3 minus 4, which is 6 minus 4, which is 2. And you could do the square root of 2. That's just going to be a decimal, right? So this is valid, but when x is like 0, right, if you have 0 here, then you're going to get a negative in the radical, which we cannot do, all right? So the domain is strictly greater than or equal to 2. So this is our domain. All right, and that's it, guys. Best of luck on the corrections, and I will see you another time.